say you want to push a box on an inclined plane, but you realize that it's not as easy as it seems due to friction. When a box rests on a surface, it experiences a downward force called gravity. Simultaneously, the surface exerts an upward force called normal force to balance the gravitational force acting on the box. But when you try to move the box, another force comes into play, the friction force. Now let's learn more about friction. It depends on the roughness of the surfaces in contact and is represented by a value called the coefficient of friction. This value varies between different materials. For example, for this box and the table, the coefficient of friction is 0.4. When you accelerate the car along a curve, the direction of the friction force doesn't necessarily oppose the motion along the incline. Instead, it acts perpendicular to the contact surface. Here's a challenging problem for us to crack. Imagine a car with a mass of 1,200 kilograms on a curved inclined road with a 20-degree angle. The coefficient of static friction between the tires and the road is 0.6. What is the friction force vector acting on the car, including its components along and perpendicular to the incline? To solve this problem, we'll start by calculating the normal force by finding the component of the car's weight perpendicular to the incline. After solving the equation, we find that the normal force equals approximately 11,764.28 Newton. Now let's calculate the maximum static friction force using the coefficient of static friction and the normal force. Upon calculation, we determined that the maximum static friction is around 7,058.57 Newton. To find these components, we'll need trigonometry to analyze the balance of forces and determine how they affect the object's motion along the incline, accounting for friction. The component of the friction force along the incline can be calculated as follows. Shortly after, we find that the friction force along the incline is about 2,409.24 Newton. Similarly, the component of the friction force perpendicular to the incline can be calculated as follows. Once completed, we find that the friction force perpendicular to the incline is approximately 6,572.42 Newton. Now you have successfully solved the computation problem and learned about statics and friction.